let's talk about reactions of acids and bases. And oops, that's not what I want. All right. Reactions of acids and bases. I can change color too throughout this, so might happen. So the first one is one that we've sort of experienced before, and that is that's the reaction of a metal in an acid. Okay, so metals can be dissolved in acidic solutions. Okay, so this is why you want to sort of keep your metal materials away from acids if you can. So let's try a simple one. Say we have some magnesium metal, and we're going to react it with some hydrochloric acid. And I believe we've done this one. Maybe not magnesium. Maybe it was aluminum or something else. But anyway, what you'll find is that you get a reaction that creates some of this and releases hydrogen gas. Okay, so you get a metal salt and you get gas. Okay, and this pretty much goes for really any metal you can think of. So let's, I don't know, they keep using magnesium as an example, but why don't we try something else like iron, say. And what happens if you put some iron into vinegar? Wait a minute. Is this what I want to show you? I think that's acetic acid. Is that acetic acid? I believe it is. Yeah, pretty sure it is. Yeah. Okay. So if we put iron nails, or even steel nails, which have a high content of iron, right, we'll find that they rust pretty quickly if you leave them in vinegar. Lots of kids do that experiment, right? Anyone ever do that before? Iron nails in? No? I believe you can actually make like your own kind of sort of paint doing this. But what you'll end up with is you will end up with the iron associating with the acetate ion. So okay, and we'll say it's iron 3 plus H2 gas. Now is this balanced correctly? Not really. We need, what are we going to do here? We need 3. We actually need 6, I believe, right? 2, 6. Whoa, whoa, whoa. No. Oh yeah, yeah, yeah. That's right. Does that seem right? Oh, yep. Sorry. There we go. Thank you. Perfect. So there we go. There's iron dissolving in vinegar. Try it tonight. Matt, take a nail, throw in some vinegar, bring it to school tomorrow. Okay? All right. All right. Cool. Okay, so there's that. Um, so let's try the reaction with carbonate. So when we looked at medicines and drugs, there's a few different ones that, a few different antacids that we came across that, that you can use as an antacid. So for instance, you might have some CaCO3, some calcium carbonate, which I believe is what is in Tums, whichever one advertises as calcium in it. I think it's Tums. Okay, sweet. And if we react that with stomach acid, which is actually hydrochloric acid, you did. And what you'll get as a result is you'll get a bunch of interesting situations. You'll get some calcium chloride. You'll get some water, but you also get some CO2 gas. Okay? Lots of CO2 gas, correct, yeah. So this is the general reaction that you have here between any type of carbonate and HCl. So when you're doing those reactions, you got to remember that, and don't forget that there's carbon dioxide created in these reactions, because some people did when they were writing these equations out. They left out the carbon dioxide, and it's really hard to balance. And you're like, hey, there's carbon left over. What's supposed to happen with it? CO2. Okay, so that's where that is. Okay, next. Well, the famous neutralization reaction. So that is basically where we react with a base. We've been studying this since grade 10, so this shouldn't be a big surprise. But one we can do is just say HCl plus sodium hydroxide. This is actually pretty much to completion with these guys. And you're going to get some salt, and you're going to get some water. Okay? This is a, this is what we're going to do when we do our titrations, right? We're going to make a stock solution, a known concentration of NaOH. We're going to add it drop-wise into a solution of HCl. Then by looking at how many drops it takes to reach neutrality, right, which we'll get with a pH probe or with some sort of indicator, which we'll describe next time. Once you've dropped in your NaOH to the point that you're at neutralization, you've completed the reaction, you can calculate what the original concentration of HCl was from the titration. Okay. Let's see, what else? Metal oxides. So metals tend to react with oxygen. You can see this with rusting. You can see this with aluminum, actually. People think aluminum doesn't rust, but it actually is quite reactive and gets an oxide coating really quickly, which is why it does not further continue to rust. That oxide coating is non-reactive. So if you shine up some aluminum, it instantly gets a thin coating of oxide on it that prevents further tarnishing. So that's kind of interesting. So let's just do a copper oxide, for instance. With, what acid is this? Sulfuric. Okay. It's a good question. I'm going to say that it probably does reach some kind of sort of equilibrium. But since we're just kind of generically outlining what's going to happen, we'll just throw it out there like that. Okay. So you get a metal. I guess you get an ionic compound, I should say, and water. And let's see what else we have to talk about. Metal hydroxide. Well, metal hydroxides tend to be bases, right? So this should be fairly, I think, obvious what's going to happen here because we already just saw one. See if there's anything that's a little more interesting than that. Not really. So these will be neutralization reactions. Okay, and it doesn't matter what acid you put in there. So if you want, what you can do is you can quickly draw a little thing here. Acid. It's metal oxide. Salt water. Acid with the metal is going to give salt and H2 gas. Metal hydroxide, salt and water, with other bases, so for example ammonia, you're also going to get salt and water, right? Essentially these are the normal bases that we're always going to be dealing with. And last but not least, the carbonate, you're going to get salt, water, and CO2. Okay, here's like the big acid spider. All right, that I think is all we really need to talk about. In terms of this, we've talked about the pH scale. We'll talk about indicators going forward. Yeah, and we can talk a little bit about the environmental implications of some of this stuff.